easy to live? Does your life can you survive under the sun? I can't put my finger on it. Is it green? Is it red? Is it alive or is it dead? I can't put my finger on it. Scared with the nails of the days in the past. I can't put my finger on it. Is it brown? Is it white? Is it really out of sight? I can't put my finger on it. Call it squeal, does it squirm? If it's fresh, will it burn? I can't put my finger on it. Can it fly? Will it try? If the wings are still wet, I can't put my finger on it. Can it heal? Is it real? Can it feel the threads of time? I can't put my finger on it. Does it glow? Will it shine? Does it leave a trail of slime? I can't put my finger on it. I said, are you surprised when I touched the blood inside? I said, are you surprised when I touched the blood inside? Are you surprised when I touched the blood inside? Are you surprised when I touched the blood inside? Is it alive? Does it life that is survive under the sun? I can't put my finger on it. Is it green? Is it red? Is it alive or is it dead? I can't put my finger on it. Scared with the weight of the days in the past. I can't put my finger on it. Is it brown? Is it white? Is it really out of sight? I can't put my finger on it.
Okay, so we left off last time talking about data projections, and the example that I gave, the visual example that I gave was 3 dimensions down onto 2 dimensions using an aggregate, where we've got a bunch of titles by a bunch of different authors. Then we use a group by, let's see, up here is where we started out with. Then we use a group by clause here to group all of the authors together. So then we can project it and aggregate it down so that we get a total number of copies, a sum of 10 and 3 by Norman Mailer to get the total number of copies of Norman Mailer books, Douglas Adams books, and then Orson Scott Card books. The example that we used on our database, which just to remind you, it's a publisher, game, platform, and the game and the platform are brought together by this availability table, right? We tried to do that with publishers. So here's a publisher ID 1, and they published 3 games. Publisher ID 5 published 5 games, ... Publisher ID 20, they published 1 game. But we immediately identified 2 problems with this. That if we look at all the publishers, there are some publishers there that are not represented, right? For example, Sony Entertainment does not have any games published. The other problem is, what about publishers with no games, right? There are going to be plenty of those because there are 21 publishers, but there are only 20 games, right? Or something like that. And so we're getting, we're not getting the name of the publisher, who they are over here, and we're not getting an accurate count of the number of games for anybody that's being left out. There should be zeros here, basically. Okay. So we're gonna solve that problem by looking at some more math here, or looking at some math here. Where is it? All right, here we go. Remember that if you have two sets, A and B, right, and one has cardinality 3, the other has cardinality 2, the Cartesian product, or the cross product of this, is going to be A cross B, where each element in A is matched with each element in B. So A is matched with 1 and 2, B is matched with 1 and 2, C is matched with 1 and 2. In general, if you have cardinalities N and M, if you just do this cross join here, or this cross product, then it's going to have N times M elements. Right? In SQL, these are called joins. Right? So let me go ahead and try that. Right? Let's go ahead and try what's called a blind cross join. Right? It's not usual to call it blind, but blindly doing this is what I'm referring to. Just a regular old cross join. Select everything from game. Right? Join publisher. Right? I just put that on 2 lines so that I don't end up with really long lines here. Right? And I'm going to get a whole bunch of nonsense data. The GTA 4 was published by LucasArts and Sony and Square Enix and, right? That's because I'm doing a full join here where everything is matched with everything else, okay? When the data doesn't make sense, but also let's do a count of this, count of the number of records here. I see 378. Remember, how many publishers were there? 18. How many games were there? 21. What is 18 times 21? Select 18 times 21. Remember, you can use this as a calculator. 378, which is exactly the number of records I get here, 378. In other words, I'm blindly pairing these things up whether or not that pair makes sense. Okay? So that's a blind cross join. And by the way, remember, what if there are 1 million elements over here and 1 million elements over here? Right? How big is that going to end up being? 1 trillion, right? 1 million millions, we call them trillions, right? So you're going to be waiting there quite a while for that to process. There's a process called pagination, so it'll probably send you like thousands of records and then wait for the network to respond, and then, okay, now I want the next 1,000. It sends you pages. Like if there are a trillion pages, it's going to send you 5 pages at a time, right? That's called pagination, okay? So let's not do this blindly anymore. Let's go ahead and make a cross join, make a join based on the relation. Right? Now let's go back to math over here. Did we do relations yet? No, we did not. All right, so let's do that. Is this right? Yeah, okay, so more math here, more. So a relation between 2 sets, A and B, is a subset. And I'll go into full math mode here, subset equal, right? We've seen that before. R is the relation, subset equal, right? A times B, right? Where you've got the full join, the full Cartesian product here, and then you're taking a relation on that, right? So for example, let R be a relation on math BB Z, and the same one, math BB Z, right? In other words, you could there's nothing saying that the sets can't be the same. When you do that, you say that it's a set, it's a relation on a set, such that A, B is in R if and only if A is less than or equal to B. There's your first basic binary relation. Eventually in 235, when you start talking about relations, by the way, why are we talking about relations? What are we talking about again? Relational database management systems, right? This is why Edgar Cod did this. He did it based on this mathematical idea, right? So for example, what about, I don't know, 5 and 10? Is that in the relation or not? Is that a pair that's in the relation? Is 5 less than or equal to 10? Yep. Is 5, 5 in the relation? Oh, yep. Why less than or equal to? We're good, right? That's known as reflexivity. So if you have a relation and it has it's reflexive, it's transitive, and it's symmetric, then you have what's called a poset. partially ordered set, right? Yeah, post set. If it's reflexive and anti-symmetric and transitive, then you have something else. So that's a post set. I forget what the other one is. Yeah. Anyway, you've got all these properties that you can endow onto sets, and you get different types of relations. But what about the opposite there, 10 and 5? Is that in the relation R? No. So we would say not in R, right? So we've got something that's in R, two things that are in R. In fact, we have an infinite number of things that are in R. What would this relation look like visually? Here's the Cartesian plane, but only integers, so all these dots instead of the real numbers. And then you draw a identity line. Everything above that is in, everything below that is out, right? And what about the line itself? Everything is in because it is reflexive here, less than or equal to. You could change that to something else. You could change it to strictly less than, and now it's no longer symmetric, but it is anti-symmetric, and you have a different type of relation there, right? Undo, undo, there we go. All right, so those are relations. What's our relation over here between the publisher table and the game table? Right? It's not just that everything in the game table is related to everything in the publisher table. We saw our folly there already. Instead, how are they actually related? Through their foreign keys. Right? This foreign key should match this primary key up here, right? So that this child record, this game child record, is referring back to their parent in the parent table through this ID right here. Right? So let's add an on clause. You do this using an on clause. Right? So we're not just going to join them. We're going to join them on something. We're going to join publisher on game ID is equal to publisher ID, right? Publisher ID and publisher ID. Right? So I'm going to select, I'm going to just select everything so I can actually see it. Everything from the game, join over to the publisher, but only for records that satisfy this relation. Just like over here, A and B is in the set only if it satisfies this relation right here. But this is the on clause in the math, right? Okay. All right, so let's see the results now. They make sense now. GTA 4 was only published by Rockstar Games. Tomb Raider was only published by Eidos, right? And we only have 21 records here, 21 games instead of 378 games. Okay? So there are some shortcuts here that you can make. So some shortcuts. Alias table names, right? And by the way, table names, right? So we're using the dot operator here. This is now ubiquitous in computer science. You've seen this in C, you've seen this in Java. You've seen this in Python, whether or not we used it or not, right? The self dot, etc., right? It's used pretty much in every language or something like that, right? So what you can do is you can take this and shorthand everything, right? Game as G and publisher as P. Those are aliases, so that you don't have to write the whole thing down here. Publisher and G and P then become placeholders for that, and you get the entire, the exact same results as before. But you can actually shorthand it even more. Since this is so common, we generally omit or elide away the as keyword here. Right? And you get the same results. So select everything from game, aliased as G, join publisher, aliased as P, and then you can use those down here. Okay? All right. So does that solve my problem up here with my report? Right? So I don't want the publisher ID anymore. I want the actual publisher name. So let's go ahead and go down to the next line here. From game G, and then we'll join publisher P on G dot publisher ID is equal to P dot publisher ID. There we go. And then group by their publisher ID. Careful. We now have two sets here. How many publisher IDs do we have? I see one there, and I see one there. And it's not going to like that I'm grouping by one of them. Which one? Right? That's what it's saying. It's ambiguous. Which publisher ID did you mean here? Well, I meant they're going to be matching, right? They're going to be equal, so it really doesn't matter which one, but generally you should prefer primary keys for this. Group it by the publisher's publisher ID. It still won't work because we are duplicating publisher ID up here, but we don't even want that. We want the publisher's name instead of its ID. And now we have LucasArts 3, Nintendo 5, etc. We've solved the first problem there. In fact, I'm going to solve it even further by saying that this should be as publisher name. Right? There we go. And by the way, yes, you can elide that away as well. Right? But I usually don't. I don't know why I'm in the habit of, I keep the as keyword when I do aliases on column names, but I don't do it on table names. Don't ask me why. Right? It's just that's how I was raised. Right? So there we go. Right? Publisher name and number of games. Okay. So there's still a problem here because what about all of those publishers that don't have any games? They're not coming up as zeros in this report. Right? Everybody is at least 1 here. Now to do that, we're going to need a different kind of join. Let me go down here. Here's the join that we just looked at. It's actually called an inner join. Right? And the one that we're going to look at here now is called an outer join, but we don't use those keywords. You can use those keywords, by the way. Let me show you. You can go inner join, and it'll do the exact same thing. But generally, we elide that away because it's understood that if it's just a join, it's an inner join. Right? Now, the idea here is that you're taking a student table with first names, last names, and IDs, and you're matching it up with an email table because one student could have many emails, right? Starlin Castro here, 1234, is matched with this over here to give us their email address right here. Anthony Rizzo there, 5678, is matched with that record, giving us Rizzo at Cubs over here. 9988, Ryan Sandberg, actually matches 2 records over here, and so we get both of his emails, and then his last name is repeated. Right? But what about Dale Sweem right here, 1122? Do you see a matching record over here in the student ID table? Nope. So consequently, he's not in this table at all. That's because it's an inner join. It does not preserve records. When you're going from the right table, the left table from your perspective, over to the right table, you lose records that have no matching records, right? Or you're going from a child table to a parent table, you're going to lose records that have a parent but no children. Okay. Here's the other way of doing this. It's called a left outer join or just left join. Again, you can omit the left here. The only difference is that it's going to preserve that Dale Sweem record that has no matching email records, filling in the blank using null, missing. Okay. Now the only difference here, let me go ahead and start with this one up here, the shortcut, right, is a left. All right, so we'll go ahead and try a left join here. Left joins. Preserve records from table A to table B. Right. Okay, so left join to the publisher. I have the exact same results as before. Because it's going from the left to the right. So we're going from the game to the publisher. I'm going from the game to the publisher. Is that left to right? Nope, that is right to left. And in case you're asking, are there right joins? Yes, I'll show it to you in a second. But what I want to do is I want to start at the one that I want to preserve records from. I want every publisher, even if they don't have any child records over here. So let's go ahead and swap these around. I'll start at the publisher table. Oops. There we go. And then I'll go over to the game table, G. Right. And if you want to, just to be consistent about it, you can switch these around too, but it doesn't matter. Because A equals B, B equals A. Right. There. Now Sony Entertainment, Square Enix, and Sega, with no records over here, right? They're preserved from the left. Because we were going from the publisher to the game table. Table A to table B. So we will preserve records in table A, the publisher table, when we go over to table B. Right? yes, there are. Okay, so actually, let's solve this problem then by adding this up here. All right, so finally, here's the full solution. I'm going to have to switch these around because I'm going to go left to right. So we'll start at publisher P, go over to the game table G. If you want to, go P and then G. All right. Oops. Lowercase g, come on. There we go. And instead of a join, you'll do a left join. All right, there we go. Now I see a whole bunch of new records. Sony Entertainment, Square Enix, and Sega. But they don't have the correct number. 1, 1. This one's still correct. 3, 5, 4, if you remember those, if you committed them to memory. Right. So why is it giving me 1? What am I counting here? I'm counting rows, right? So when I come down here to Sony Entertainment, there's 1 row there. That's what I'm counting it for you. Right? What should I be counting instead? For LucasArts here, 1, 2, 3 things. For Sony, 0 things. Treat null as 0. For Nintendo, 1, 2, 3, 4, 5 things. Right? In other words, I should probably count that which is unique. Right? In this case, it's the game ID. G.GameID. Right? Not rows, but records of the things that exist. And now Sony Entertainment, Sega, Square Enix, they're all zeros now as the number of games. So be careful on your left joins versus your right joins, or your inner joins. And yes, right joins exist. I'll show you. Right. Let me go ahead and grab what I had before. I'm going from the game table to the publisher table. Without switching them around this time, though, I will go with a right join. It'll preserve records from table B going over to table A. Right. And we've got Sony Entertainment, Square Enix, and Sega, and you know we swapped them around. Before it was like this, now it's like this. That's why it's appearing on the right-hand side over here instead. Right? But the records are preserved from the right, right, as you go to the left. Right? But who reads left to right? Right. I don't like reading right to left or bottom up in this case. Publisher to game to see the right join. Just read left to right, right, and do and save yourself some headache that way. However, sometimes it is necessary. Right? Dot dot dot. Right. What I want to do now is I want to come full circle. We started out with flat files like this, CSV files. And then we introduced a relational data model where we separated things out into tables. We'll be making our own tables starting Wednesday. But we separated things out into different tables. Those tables were related through foreign keys. They were uniquely identified through primary keys, right? They actually had types like varchars and strings and integers and doubles, right? Let's come full circle now. I want to go back to the beginning. I want to flatten this entire data model. Flatten the entire data model. In other words, I'm going to go for the relational model back down to CSV files so I can give you a bunch of CSV files. Right? Right. So how are we going to do that? Let's start at the publisher, go over to the game table, availability, and then platform. The entire direction, all 4 tables, I'm going to join, join, join. I'm going to left join, left join, left join, because I want publishers to be preserved whether or not they have any games, whether or not those games are on any platform. Okay? So select, just for now, everything from publisher P, left join, let's go up there, left join. Right, game G on P.publisher ID is equal to G.publisher ID. Right. Left join availability A on, it'll be the game, so G.game ID is equal to A.game ID. Oops, commas, what am I doing with commas? Right. Left join, and then finally the platform table, platform P on availability.platform ID is equal to P.platform ID. Do you notice how I never even looked back at my ER diagram? and yet I was able to remember all the names. Why is that? Tell me about all the primary keys here. What are they named? The table, slap an ID on the end, right? All the foreign keys are the exact same name and type as the primary keys that they refer to. Right? All of the table names are singular and all lowercase. You can go more modern and do upper camel casing if you want to. We'll do that actually. But I didn't have to do any guesswork here at all, right? Because I had consistent naming conventions. Let's go ahead and execute this. Oh, non-unique alias P. Publisher P. Game G. Availability A, but platform P. Can I use that twice? Should I use P2? Gross. Go with plat or something more descriptive there. Plat, short for platform, right? Or just don't use an alias if you don't want to. Sony Entertainment is retained all the way over to the right. Okay. Now there's still a problem here, because if I look at all the platforms, which we never actually looked at, select everything from platform, right? Xbox 360, Switch 2, Index and Playdate are three that I just added in another section. So let's take a look at, remember those, Switch 2, Index, the Valve Index, and the Playdate, right? So let's execute this and see, are those represented over here? I see Game Boy, Index, oh, there is Index there, and there's Playdate, but is Switch 2 on here at all? It goes from PlayStation to Super Nintendo to Xbox. So Switch, what about that Switch 2? It's not being represented. Why? Because we went from the left to the right, right? 1, 2, 3, 4. Anything that doesn't have a matching game record over here is lost. So let's go in reverse. I don't want to have to type too much. So let me just go ahead and go with a right join, and a right join. And we'll see over here that now Switch 2 is represented on the right, not having any matching records from the left. Careful. What just happened to all of the data that I went from the preserved from the left to the right? Say like Sony Entertainment. Where are they now? Gone. Right? So you can preserve from the left or you can preserve from the right, but you can't do both. That's where some more set operations come into play. So here's some more math. Set operations. Right? If you have a set A and B, what is the following? A, B, cap, and cup. That's the LaTeX for it, by the way. Now let's do that one up there first. Okay. So what is that first one? The cup. Union, right? What is that second one? The cap. It's and it would be so. This would be the or union. This would be the and, which is the in set theory we call that intersection, right? So Venn diagrams, right? You've got A and B, and then the intersection is in between. The union is all A and B and the intersection with duplicates removed, right? So I'm interested in the union here because I've got a set here and a set here, but I want them combined. So combine them using the union. There we go. And now Sony, Square Enix, Sega, they're all preserved, but also Switch 2 down here is preserved from the right. Can you do intersection? Yes, but I don't think it makes, you got to intersection. Intersect, maybe. No? What is it? Intersection? No, maybe you can't. All right, so we're going to have to look this up. SQL intersection keyword. What is it? I don't think it's intersect. 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 All right, it's not liking it, but it runs it. So don't ask me. That's a bug maybe in MySQL Workbench. I should have trusted myself and said that yes. So what did you lose here? You lost everything that was preserved in both directions, right? You lost. You only preserved everything that went back and forth, both of those, right? So intersection is different. And let's go back to union. Right? Don't ask me why it's not. It's a keyword. Don't ask me. Anyway, there's the entire flattened data model. And by the way, you can export it as a CSV. We've come full circle. Or you can do it as like an XML, like you just did, or JSON, like you just did. Or you can actually export it as a bunch of series of SQL insert statements. Right? There are websites that you can take any one of these and translate it to any one of the others too. Right? But these are all structured. Right? Okay. All right. So we went full circle there. I want to stick on Crud because what we are going to do next time, I'll give you a preview of it. But what we're going to do next time is we're going to design and implement our own database. And we're going to do so with that asset classes that we used, that we designed, the asset, the annuity, the stock, the person, who's the owner, and of course their emails, maybe their address or something like that, right? In other words, this thing right here that we did. That's a UML diagram. I want to do an ER diagram of that, right? And the ER diagram is going to be for databases. Generally, the guideline is you've got one class to one table, but that's a guideline, right? Ultimately, what we're going to do is we're going to take these three classes and shove them down into one table. Something that like the email, which is actually a list of strings, right? That's still a one-to-many relationship, so that's going to be a separate table, even though it's just one string, right? So it is going to be a little bit different. It's not going to be an absolute one-to-one correspondence between the database and our UML diagram here, but we'll get to that. Okay. Instead, what I want to do is let's do some more exercises here. So insert data with special characters. Right. So for example, insert into game values. Let's say name and publisher ID. Values. Luigi's Revenge. I don't think that's a real game. But what was Nintendo 5 for publisher ID? All right. What's the problem there? Yeah, apostrophe. So what are we going to do to solve that problem? Escape it. Right. The alternative, of course, would have been to use double quotes instead, and then you can use single quotes. But what if you want to put double quotes in your data? Then you need to use single quotes. What happens when you not want to do both of them? You're going to have to escape it eventually. Okay. So inserting with special characters. And by the way, can you do special characters like, say, emoji? I don't know. Let's try this. Smile. I don't know how to type them, so I'm just going to have to copy and paste. Copy and paste. There we go. Let's see if it works. Nope. That Unicode is not escaped. So that's probably good. Right? Oh, whoa. That won't work either. Why did it do different? Copy. What if I put it right in the center? But if I paste it a second time, paste it right there. Okay, I don't know why. Oh. All right. I don't know what it's doing there, but don't screw around with the Unicode characters. This is, you can if you want to, but this has been set up. Let's say describe game. I don't know if it'll give us enough information here. Yeah, so SQL describe with details creation. Yeah, describe table structure. It's not going to give me that. Oh well. Anyway, these were created using ASCII text table for its characters, so that's why it's not letting me do an emoji like that. You can go ahead and set it up so that it supports Unicode characters, but you have to make absolutely sure everything is correct. But you can do that. So anyway, inserting with special characters, the special characters right there. By the way, tab characters, end line characters, etc. Right? So I'll go ahead and leave it like that though. Right? Let's go ahead and create a report that details for each platform how many games are published are available on that platform. Okay. So let's come back over here and look at our schema. So what tables will likely be involved? Will publisher be involved? Maybe. Certainly platform. I want the platform's name and then the number of games that they're published on. Careful. Do I need to go all the way to the game table over here? Nope. I just need to go to the availability table. If that platform ID is represented over here, then it'll have a game ID that I then can sum up, or that counts the number of game IDs. Do you actually need the names of the games? No, you're just going to give it a number. 5 games are published on this platform. 2 games are published on that platform. Be careful. 0 games are published on Switch 2. Right? So let's go ahead and start at the platform table. Select everything from platform, P, left join, availability, A, on P dot platform ID is equal to A dot platform ID. All right. So that'll get me the platforms. That means, you know, Xbox, Xbox 360, NES, all the way down to Switch 2, with preserving records because I did a left join there. Okay. I could have done a right join, but then I would have to start at the availability and then go to the platform and read right to left. I don't want everything now. What do I want in my report? I want the platform name, so p.name as platform name, right? Or what's another word for platform? Device, console. But what about PC though? PCs and consoles collectively are device. That's probably why I called it platform name. You can go old school and do underscore conventions there, right? There we go. We're getting Xbox, Xbox 360, etc., etc. Right? But I'm not getting a report on the number of games. So count of, is it star? That'll end up being all 28 for Xbox, or all 29 for Xbox, right? All right, so I don't want to count just everything. What do I want to count? Things that are not null. Game ID. And where is game ID? It's in the availability table right here, because we didn't go all the way to the game table. So a.game ID. Now we're down to 28 because we got rid of that one platform that had 0 games. But we're still getting only one result here. Everything is published on Xbox. If you're going to be doing a projection and aggregate like this, what else do you need at the end? You need to group them by, and how are we grouping them? By their platform. P.platform ID. Right? Always group by something unique, but a primary key. Right? Xbox has 1 game. Xbox 360 has 3. There's that Switch 2 down there with 0 records. All right, let's go ahead and give these more descriptive names. There's already the platform ID, count as number of games. I'm going old school here. Lower underscore casing, right? Lower underscore casing, okay? Except that now I don't want that, right? But only if they have a substantial, that is, more than 3 games on them. ... All right. Well, traditionally you'd use a where clause here, right? Where number of games is greater than 3. Greater than 3. Right? That's not going to work. Where clauses are for filters. You would do that before your projection. Here's where a where clause would be if you wanted one. Instead, we have to have a different keyword here. It's called having. Right? So group by their platform ID, but only having number of games strictly greater than 3. Right? And there, NES and PC are the only 2, with 4 games and 8 games respectively. Right? So if you want to filter prior to projecting, then it will be a where clause, but that's before the group by clause. If you want to filter after the grouping, after the projection, then you have to use the keyword having after that. Okay. All right, cool. What else could we do? We've got 10 minutes. All right. Oh yeah, the one we did in the last class here is recall that you can determine the oldest game. All right. That oldest game is going to be select min from publish year from availability. There we go. 1985, but that doesn't tell me what the game is. Now that we have joins, we can do that. Select everything from game, G, left join, availability, A on G.GameID is equal to A.GameID. Right. There we go. And I will get, now where's that publish year? If I sort it, I see, oh, Super Mario Brothers, 1985. All right. Now I've got that information, but I've got all the information. Right? I just want that one game. Who is that 1985 game? Now, first of all, do I have to do a left join here? Going from a parent table down to a child table, do you have to preserve parent records? Right? Not necessarily. Right? If there's no children here, then could they have been published in 1985? No. The only reason that I would want to preserve records is if I want these null values here because I'm going to count them. But null doesn't tell me that it was actually published in the year. In fact, it tells me it wasn't published at all. Right? So I'm not going to bother with a left join here. That automatically cuts down on the amount of data. Right? But now I want a where clause, where a.publish year is equal to 1985. Now I've got that one game. Is it guaranteed to be unique, by the way? Duck Hunt was also published in 1985 because they were packaged together, right? So with the NES light gun, right? Very, very cool, right? But I don't have any records in there. Oops, sorry. I don't have any records in there for multiple records for 1985, right? That's why it's unique, right? It's not necessarily unique is what I want to say, okay? Also, I don't want to hard code that to 1985. Hard coding values is okay for test data, but not real queries, right? Okay? So what I'm going to do is I'm going to take this and I'm going to make it into a nested query, right? So a join with a nested query. And now I get Super Mario Brothers published in 1985 without having to hard code that 1985. Because you can also get the newest game if you just change this to a max. Right? Now it's Assassin's Creed 2025. Right? I put that in there as dummy data. It's not real data. Right? Okay. What else could you do with this simple four-table database? We've flattened the data model. We've done a report on publishers to games and platforms to games. Right? I don't know. It's simple enough that I think we just exhausted everything. Let's look at one more issue. Insert into game, name, publisher, ID, values, and then lorem ipsum, ipsum. I'll come back to that here. 10, and then let's actually look at a lorem ipsum generator. So I want something large here. Paragraphs, 5 paragraphs, generate it. All right, there's my 5 paragraphs. All right, lorem blah, blah, blah. It's just nonsense Latin. And you can't read it because nobody reads Latin, and so you know, oh, it's a placeholder there, right? So let me go ahead and put that stuff in there, okay? All right, I'm about to execute this. All right, Eric, data too long for column name at row 1. The name, how big is it? 255 characters maximum, right? So what happens when you try to insert something that is larger than that? An error. Did it actually work? Select everything from game. Nope, it didn't work at all. Sometimes it'll be truncated instead. So I don't know why it's not being truncated here, but whatever. Sometimes it'll truncate it and it'll just take the first 255 characters and then put the data in there for you, right? Thankfully, it's been set up sensibly here to just reject that data entirely, right? So stuff that is too long is an error, not truncation. What about insert into game, name, publisher ID, values, Mario's Revenge, and then 1,000. Right. We certainly do not have that many publishers in there. What's going to happen? Error, because there's nobody with publisher ID 1,000. Right? What if I did 50.65? Also, there's nobody in there with 56.65. But what if I did 10.5? Now 10, there's certainly somebody in there with publisher ID 10. We can kick it down to 5 here. Right? Oh, it worked. What happened? Careful. Let's find out. Select everything from game. There's Mario's Revenge. What did it do? Yeah, round it up. What the hell? Right? It should have at least been truncation. Right? Not truncation, not an error. Rounds it up for some reason. So, no. Let's find out. We can still do this because we don't have any uniqueness constraints on the title. So let's find that out. Select everything from game. There, 6 and 5. So it is definitely rounding up and down, right? Rounds for some reason. Okay. Weird. Weird stuff happens when you do weird stuff, though, right? So don't do weird stuff. Right? Everything in here is going to be an integer. Right? Everything in here is going to have a sensible name. Everything in here is going to have a sensible maximum number of characters. Okay. How else could we break this? Yeah. Oh well. That's fine. Oh, by the way, then when I flattened the data model, I didn't bother, but there were 3 name columns. There's another perfect instance where you would want to alias those. Right? Okay. All right. No questions? Oh, like a nonsense column? Foo? Yeah. So. Yeah, it's going to be an error in that it doesn't know what foo is there. Right? Yeah, unknown column foo. Right? Likewise, if you have a disparate number of columns here, just one column here, but then 3 columns over here, it's going to say the column count is off. Likewise, the other way around. So thankfully, it prevents a lot of that stuff. But yeah. Right. They talk about how to reset passwords. Reset your password. Now that we're fully into it, you can. Yeah, I did. Set password equal to password. A call to this function that hashes it using MD5, unfortunately, but then put in 1, 2, 3, 4, whatever password you want to change this to. I am not going to do that because I've already set my password. Right? Can you list your password? No. Maybe you can. I'm not sure. Can you drop your database? Drop database. Seberg3. Right? Yes, but I'm not going to do that because then you'd have to create database. Seberg3 to restore it. And by the way, if that's not a restoration, all your tables are now gone. You need to reinstall those tables. Okay. So those things will be put into the notes, but I'm commenting them out so that you don't do them. Right. All right. So, all right. If there are no questions, then what we'll do next time is we'll come back and we'll start designing these databases from scratch. Right? Because this one was already given to us because I like to start out with CRUD, right? Create, retrieve, update, and destroy, so that you get a feel for what a database should look like and the contents and stuff like that. Now, how do you actually design it from scratch? Okay. I'll see you on Wednesday.